So there's also one thing to consider is that when we have the term redox, a reaction cannot be a redox reaction if there aren't both parties involved in the reaction. So it must have both reduction and oxidation. And I'm going to, well, it's actually called half equations. Now we can, well, since redox is split off into two words, reduction and oxidation, there are two parts to it. So the reduction half equation and the oxidation half equation. So in every redox equation, there must be a reduction half equation and an oxidation half equation. So that's all that's saying. Now, another piece of terminology are agents. So here I'm going to write down an oxidizing reagent. An oxidizing agent. Now this is going to confuse a lot of you when you do your questions and whatnot on this topic. So if you refer back to acid and base chemistry, remember conjugate acids and conjugate bases. So if I have an acid, I'm going to end up having a conjugate base that's paired with it, and if I have a base, I have a conjugate acid. Okay, so they're paired off. So what conjugate actually means, and I'm just going to write this down, conjugate actually means the opposite role of. So when we're talking about an oxidizing agent, we actually mean that a certain species actually likes to undergo reduction. Another way of saying this is that in a redox reaction, it accepts electrons. Stuffed up again. Now, conversely, for a reducing agent, this likes to undergo oxidation. And likewise, it likes to donate electrons. Now let's take a couple of examples. So let's say that we have iron 2+, and we are actually going to go to iron plus. So to balance out this equation, we actually need to have equal charge on the left-hand side and the right-hand side. So if I have 2 plus and I want to get to plus, I want to add 1 negative charge onto the left-hand side. So this half reaction is actually a reduction reaction. Reduction half reaction. And if I just have a little circle, this is going to represent an oxidizing agent. It's an oxidizing agent because this half reaction is liking, it's a reduction half reaction, and it likes to accept electrons, which is on the left-hand side, sorry. The left-hand side of the half reaction. Now let's have another one. So if we have a second example, and we go from lithium metal to lithium ion, or the lithium cation. To balance this equation, or this half reaction, we need to add 1 electron onto the right-hand side to balance out the charges. As lithium has a 0 charge, lithium has a +1 charge, and the electron gives a -1 charge. So the right-hand side is actually, its total charge is 0. So because the electron is on the right-hand side, this half reaction is actually an oxidation half reaction. Or half equation. And in red, I'm going to circle the lithium, and this is a reducing agent. The reason why it's a reducing agent, because this half reaction is undergoing oxidation, and also lithium is losing an electron. So the electron is on the right-hand side. So that's all I have for this section, this introduction video on redox chemistry. The next video will be covering oxidation numbers, which is a really beautiful way of succeeding in this area of chemistry. Alright, see ya!